Jointed rods. First question, tube problem. Question number 1. A uniform rod AB of weight W is jointed smoothly at B with a uniform rod BC of equal weight and equal length. The rods are in a vertical plane with the ends A and C on a smooth horizontal plane and the angle ABC 60 degrees. So how this? If we draw that diagram, something like this, and they kept this both other extreme on a horizontal plane. This is B, A, C, no? Two rods. Two rods AB and BC smoothly joined at B, A and C kept in a horizontal plane. ABC 30. The system in equilibrium by a light string connecting the points A and C. So they connect this to a light string. Therefore, you are expecting a tension force, tension TT. Opposite and equal tensions available. Okay, two tensions. Okay, two tensions here. Find the reactions at A and C and the reaction at B and the tension. Okay, first question. Find the tension, one problem, and the reaction A and C, another question. Also at the B, completely you will resolve this problem, right? Therefore, first I mark the forces W at midpoint. The length, I say 2A is the length, the AA. If I take the length is 2A, each A and A, right? And next one, here it's touches the horizontal floor or the ground or any plane. I gives a force, say R. The symmetric figure, they have the same R here, right? Same R here. Okay. And here what? This rod gives a force. I take the horizontal component is X. Here also X. Horizontal component, opposite and equal. Also we have the vertical component. Mark upwards if I say Y, then downwards also Y, right? You know, this is a symmetric figure because two equal rods, weights are same. Therefore about this line through the B, system is symmetric. So we worked last lesson. The rods are, the framework is symmetric, but the force parallel to the symmetric axis, that is 0. So here straight you can say bisymmetric Y is 0, bisymmetric Y is 0, right? As I shown, I proved the two methods by using the Newton's law method, Newton's equilibrium method, and by following the formula also, or getting equation moments, and also I shown. Okay, so they say this is 60 at the question there, the ABC angle to 60 degrees. Therefore, actually I have here 60 mean what? The triangle is isosceles at the moment, but later it become equilateral, ne? Here 60, here 60, also 60. So 30, 30, right? So very first question. Already worked last nearly four problems. We complete the 2020 also. Very simple question, right? So study some more ideas of jointed rods, how to build up. Okay, very first they ask find the R, find the T, find the X and Y. Y is 0, they have X only. So what the method? We first find the R, no? For system, vertically resolve, vertically R 2R equal to 2W, okay? Therefore R equal to W. For system vertically resolve upwards, 2R equal to W. System mean what? Opposite equal forces are vanishes 0. Anyhow, vertical force only the R and W because of Y 0. Okay. Next we find the tension force or the X value. First we complete the T. How to find the T value? Most question in the jointed rods are by taking the moments. See, for rod AB takes moments about B. For rod AB takes moment about B. So write sentence for rod AB. For rod AB take moments about B. Write the B and can I write the R direction? Or can I say the T direction, TT? Any direction you can apply, put the T direction, right? We find the T first. So why I said about the point B, then you have T, R, W. R comes to that moments part. You know the R value, you know the W, then you can find the T answer, right? You will properly decide which point most suitable take the moments. So for rod AB takes moment about B, this direction T into the vertical for distance 2a cos 60, 2a sin 60. Okay, 2a sin 60. Here 2a cos, I need the vertical, 2a sin 60. This minus R, now minus R, other direction R, other side, ne? So minus R is the line of action of the R. Therefore this one what 2a cos 60 mean, I need this one 2a cos 60, right? Here 60 mean, here also 60, ne? 2a cos 60, 2a cos 60, that's all. Algebraic summation is 0. For equilibrium, moments theory, algebraic summation equal to 0. Now, okay, is that W, we have W also, W there, W that same direction, is it? Same direction, same that side, therefore plus W, and line of action here, distance is A cos 60, okay? A cos 60 equal to 0. Divide by A, cut by A, and majority divide by cos 60, divide by cos 60. Then you have 2t tan 60 minus what is R, W, R4, then 2W, I divide by cos 60, okay, plus W equal to 0. Is it okay? Divide by cos 60, right? Divide by cos sine over cos tan 60. 2t available, R4W, and 2W then, that is 1W, right? Therefore 2t tan 60 equal to W. Tan 60 root 3, ne? So T answer W over 2 root 3 is the answer, tension. Or you can remove the irrational, that irrationalize the denominator, multiply by root 3, get the T answer, right? Okay, so R completed, T completed. Next find the X value, the hinge B reactions. It has only the horizontal reaction because of symmetric diagram, right? How the easy method? There's so many, but the easy method. For rod AB, can I resolve horizontally? Resolve horizontally. For rod AB, resolve horizontally. X that side, T this side, no? X equal T. Therefore, what is T? Is W over 2 root 3. Also, you can write that's equal to what? resultant at the hinge or joint B. That's the resultant at B because of Y is 0, no? That's the reaction at B. Resultant or the reaction at B is that, right? This is the first question. Today's second video. Also that jointed rods. Second question is that. First question. Say second question. Second problem or in similar type. Second question. A uniform rod AB, weight W, and a uniform rod BC, whose length is equal to the AB, smoothly hinged at B. Same idea. The two rods are kept in equilibrium with the ends A and C touching a smooth horizontal flow and ABC angle 2 theta by a light string connected the midpoints of the rod. So, body ideas. Here the strings tied to the A and C lower extremes, but here what? Midpoints, ne? And draw the figure first. Draw clearly the equilibrium posture. Don't join the two rods. Leave a small gap, right? Small gap and show. So here B, A and C, right? So the two rods kept in horizontal flow. The both hinged at B, no? So let's say the weight is equal to W, right? Two rods are kept in equilibrium. But under the forces, here weight is W, and here a force W weight. Okay, W. And what else here after? This gives here, I say like earlier diagram X, opposite and equal, that side X, equilibrium position. And can I write my upwards Y, downwards Y, right? Downwards Y. Okay, and this is also symmetric diagram, ne? So therefore reaction by this flow R, here also R, otherwise you can say R and S. You can mark R and S, but here both are same by symmetric. This is symmetric line. Also they say these two rods to avoid the collapse, it will come like bracket to each other, collapse to each other. Therefore they put a right rod, or they say a string tied. Actually the tension should be thrust. They ask say the tension word. Therefore we mark the tension side arrow T here, opposite and equal here T, right? And we take the length of the rod is 2A, therefore here A, here A. And you can write a sentence below. Bisymmetric Y is 0, right? Bisymmetric Y is 0. A symmetric figure, bisymmetric say Y equals 0. Earlier we complete for 60 degrees angle, all are equilateral triangle. Here not like they are marked as a theta, no? Here they said one angle is theta. So how this here for equilibrium ABC 2 theta, right? Therefore here theta, this side also theta, right? ABC equal to theta. Therefore theta 1 the same angle, right? So what the question, the problem is find the reactions at the point A and C. That means R. Here after horizontal, vertical component at the joint B, also string tension. So well balanced question. Actually 2020 is easy than these things. Take short form. I hope you complete that one. If in problem tell, I can show once again that take moments and all. Okay, very first you write that by symmetric Y is 0, right? By symmetric Y is 0. Okay, by symmetric Y is 0. Next for system, vertically resolved. What happened? R2R equal to 2W, right? Therefore R equal to W. Okay, that's the reactions at A and C, the given by the flow, horizontal flow, smooth flow, no friction here. Some questions come friction, that means roughs, then we can take the friction also. Okay, next we find X and T. So follow similar earlier type question. So Y is 0, right? And how to find the XT? Can I take rod AB, right? For rod AB takes moment about B. For rod AB takes moment about B. Then you have R, you have W, you have T, right? You know what is R, you can find the T. So study problem by problem, the moments principles. So you can write the sentence for rod AB. For rod AB, take moments about B, takes moments about B. Can I write the T? T ne ahala tiyena damu T patta. Direction like this, T that side, and that side called anti-clockwise, right? So if we take about B, T is positive, T is positive. If any problem about the direction, take vertically up, W line of action somewhere infinity kila kiyanne api. So W is the line that also come there as T direction, right? W and T same direction, R other side, the R other side. So W positive, T positive, R negative. But its moments, distance, force into distance. So complete that form. So what that T into, what the distance, the line of action here, T, what the distance here? A cos theta, okay, A cos theta, T into A cos theta, okay, T into A cos theta, T, and W also same, ne? Plus W into is the line of action, what is that force distance, this one, what is that here, A cos mean A sin theta, right? A sin theta, minus R into R is the line of action of the R, line of action of R, but the distance, this one, 2A, here cos theta, here sin theta, okay, 2A sin theta equal to 0. So find the T answer, you know what is R. So therefore here you can divide by the sin theta, majority sin theta, cut the A, divide by the sin theta, also apply R for W. So T cos over sin cot theta plus W divide by sin theta. Here R is W, ne? Therefore minus 2W, okay? W minus 2W. Therefore the answer T cot theta equal W. So what the tension? W tan theta. Okay, one no got kina tan theta, ne? Is it okay? W tan theta is the answer. Tension in the string. So R okay, T okay. Now come to the X. So they ask find the vertical and horizontal component at the point where that vertex B. But you know Y is 0, therefore X is the reaction. Horizontal component only here, right? Next, how to find, follow the previous method. For rod AB, what are the forces AB? T, X, R, Y. T, X, R, Y. What are the horizontal forces? T and X only. So resolve horizontally. One is there, other one is other side. X equal T. For rod AB, horizontally resolved, what happened? X equal T, ne? X equal T, right? So what is T? W tan theta. W tan theta, X equal T. That is W tan theta. That is the answer for result or reaction at B. If they ask reaction, particular hinge or the joint, but the answer square root of x square plus y square. Here y is 0, no? Therefore x, right? So second problem is completed. See question number 3. So if you work better, so better than watch this to now you are working before you try, then only it's very interesting. That's why I'm sending these tubes already. So question number 3. The framework in the shape of a square made by joining 4 uniform rods. So maximum we have 6 rods. 6 rods is the question, but nowadays new when combined recent years 3 or 4 rods is the maximum. 2020 there are 4 rod, now 3 rods, one like a shape 1 2 3 rods. 2020 3 rods. So third question, the framework in the shape of a square made by joining 4 uniform rods. Length and weights are W. Equal length, weight is W. Is suspended from A. Square shape is maintained by a string connected the joints A and C. Okay. So draw the diagram. Draw a clear diagram. So square, show a square shape, ne? Square. Just you draw a rough diagram and see whether it's correct. If the problem, you can rearrange the shape. So 4 rods. We can put a name A, B, C, D, S. It's touch suspend from A and F to ceiling. Huh? Here A, B, C, D. A, B, C, D are suspended vertically, right? Therefore, here is a tension, that is T naught. I say T naught. At the top, it's suspended, right? All are equal length, weight also equal, right? So sometimes what happens if you throw like this, become collapse or this break cannot be equilibrium position. Therefore, they said they maintain that equilibrium. The joints A and C, here A and C, they connect A and C by a string. Actually that should be pull both sides, no? This should be a pull up and down. They say string, sometimes they say light rods. There's a rod, light rod, heavy less, that weightless rod. Here they say that string touch to that. So the question is the tension in the string and the reaction in B and D. Reaction in B and D. Okay, so complete a nice diagram, mark the forces clearly. Then you can easily complete the answer. Diagram is very important. Static chap, not like dynamic statics. Diagram, force diagram important. A, B, C here D. Okay. So if I mark these forces now, what the first force? They are weight W act vertically down, right? So at the midpoints, ne? So here W, the same here vertically down W, and here does same line of action, ne? W also W, right? And here T, tension the string, ne? Tension. Also, can I write this hinge C, joint C, break the or resolve the joint C? I will mark one horizontal force here X. Okay, for opposite and equal, that side also X. Okay, and can I mark one comes the upwards Y, then this side downwards Y. Show clearly everything. This also symmetric figure, right? Symmetric figure because of. Why symmetric? All length, all sides are equal because of equal rods. Their weights are equal, right? So symmetric about this line, AC line. About the AC line system framework is symmetric. about the line AZ, framework is symmetric, right? Also here force, here also here force. They ask what are the reaction at B and D. The both are same, both same force come that side also. I break one side, show. Here can I write x1? But kalpana down make ala make a pattern x1. And therefore when you show x1 here, Newton's law, opposite and equal that side. Here I say y up ne, therefore it should come downwards. Put the kalpana down. No problem, minus a, uttara minus a. Answer minus a, no problem, full marks. Direction only change once it come negative answer. So same, make I won't show that one. Same direction, same forces at the joint D also. Okay. And what about the angle? Square, all the angles, vertex 90 degrees, all the angles 90 degrees. You know, diagonal bisect, therefore 45 degrees. The same here, 45. Draw big diagram, then only gonna need, that's all the system. Okay, next go to the answer. Find the tension T answer and reactions at A, B and D. So this is a symmetric diagram. Then write one step that by symmetric y is 0. By symmetric AC symmetric line, no? AC is a symmetric line. Symmetric passes through the y force parallel to the symmetric. So y is 0, right? You can write sentence by symmetric y is 0. So here also we have forces a method. One is that side, this side. Here also you can mark that I avoid because they ask the main part at C, at B and D and the tension. Okay. Now come to the work of that. Always this is a simple method, right? Y is 0, Y is 0. Okay. See that. For rod BC takes moment about B. For rod BC takes moment about B. What happened? X there, W there, T there, no? For rod BC takes moment about B. Then X available, W available, T available. Then you can find one answer, one pair of equation in terms of X and T. Okay, for rod BC, if I take moments about B, W available, T available, X available, Y is 0. There have one equation about the X and T, right? The same if you take other side for rod CD, moments about D, another pair of equation X and Y, T. That is one method. You can solve the both and calculate the X and T. That is one case. Okay. See, I am always taking a simple method. First I find the X answer. See, first we find the X answer. Quickly, straightly X soya ganda puluvam. See that for rod AB and for rod AB and BC, we call half system. For rod AB and BC, take moments about A. For these two system mean there's no force at B, becomes 0. System, no? So opposite up y1, down y1. Here x1, that x1, 0. Therefore this is completely 0. T won't come, T n and A because of A, through A, no? If a force passes to a particular point which is taken as a moment point, it won't comes at 0, no? So T won't come, T passes to A. Therefore for rod AB and BC, takes moments about A. Yeah? Place where it X put the X direction. I say length is 2A, yeah? The rod length is 2A. We take all the length are 2A. Usually take like the A cancel, right? But it's X into vertical distance, what is that? 2a cos 45, 2a cos 45, 4a cos 45, 4a cos 45, okay, x, y 0, t also passes to a, if y not 0, no problem, y won't come, because you can't take it that one. How the w, see? Can I take this both the same line of action, w, same? So minimize the method. 2w, come 2w. That also x direction. That also x direction, okay. Plus 2w. What the distance? What the distance? Line of action here, this one. What that? A cos 45, a cos 45. Here a sin 45. Okay. This is equal to 0. Here's the method. So I think my answer comes negative. X becomes minus answer, no problem. Not a wrong answer. Direction different. So divide by what we call sin 45, cos 45, no problem. Both are same. No? So 4x plus 2w equal to 0. So x equal minus w by 2. Okay. X equal minus w by 2. Follow this method easily, you will find that. Now what? For rod BC, but take moment about B, take moments about B. For rod BC, take moments about B. X and T available, W also NMIT. You know X, then find the T. For rod BC, okay, for rod BC, take moments about B. For rod BC, take moments about B, this direction. X into, what is that? 2a cos 45, right? 2a cos 45. T also same, ne? Plus t into here distance from the line of action, vertical line, no? Distance, what is that? We say 2 cos 45, 2a sin 45, 2a sin 45. The force W. What is W? Take about the B, you know that x direction, T direction, W minus other side, minus W into what is that? This part direction. So A cos 45, A sin 45, no problem. 45 degree sin cos both are same, no? Okay, WA sin 45 equal to 0, right? Cut everywhere by A sin 45, A cos 45 cancel. So write the x. Don't put x for positive. What's your answer? That is you have to substitute here, right? What is 2x minus w? 2x is minus w plus 2t equal to w. Therefore 2t equal to w. Therefore t is w. D is W. T answer, tension in the string, that's equal to W, right? One of the problem. If you compare with this 2020 simple question, 2019 80 will see every problem. This is one of the big problem in the exam part, half question. Other one become framework, light rods. This is heavy rods. Other B part is about the light rods. Okay, now come to the final part, reaction at B and D. What is at B? The same comes at D. Yeah? For that, the easy method. For rod BC, resolve horizontally. X there, x1 here, x equal x1. For rod sentence important for future knowledge. For rod BC, resolve horizontally, x equal to x1. Therefore, my answer negative ne. Therefore, that also negative, right? X1 answer is that. Now resolve vertically. Resolve vertically. Here y0 t available, y1 available, w available. Otherwise take moments. Otherwise take moments about for rod BC. For rod BC take moments about C. For rod BC take moment about C. Or otherwise for rod AB. For rod AB take moments about A. Then x1 available, y1 available, you can find the answer. You know the x1, you can find the y1. Or otherwise for rod, the same thing for rod BC, horizontal column, vertical down, the vertical upwards. What is that? T up, y1 down minus, w down minus equal to 0. Y is 0 ne? So what is that? You know T answer w. So if you simplify it, okay, w. So y1 is 0. Check value, y1 is 0. T for w, the T for w. T minus y1. If you have any doubt, I can show another method also. For rod AB, take for rod AB. Wait, method for rod AB. For rod AB. For rod AB, takes moments about A. Take moments about A. Or for rod BC, take moment about C. Both come similar, the same idea, right? For rod AB, you have the answer. For rod AB, take moments about A. For rod AB, take moments about A. Can write the y1 direction, this one, y1 direction. Y1 is the force. Y1 is the force per distance 2a sine 45. 2a sine 45. Y1, that's the next other side, ne? Minus x1, minus x1, minus x1. Minus x1, 2a sine r cos, no problem, cos 45. W available, see the W, that is minus W minus W a sine 45, a sine 45 equal to 0. Therefore see a sine 45, a sine cos all same, cancel. So y1, what is minus 2x? You know that minus w minus plus, yes. See, if you doubt, y1 0, y1 0, y1 0. Therefore, total reaction at B. Therefore, I am sure the both methods, right? Therefore, reaction at B. Reaction at B and D, B and D is equal to x1. Is equal to x1. Or you know the y1 squares. Reaction ki lapo square root of x1 square plus y1 square. No? So you know y1 is 0, therefore x1. So in this case positive. In this case positive. So what is that? W by 2. W by 2. If you write your x1 for minus W by 2 square is positive. No? If you take outside, becomes W by 2. That's the reaction at the hinge B, right? Both comes the same. D, B and D are same, right? This is my question number 3. Next problem 4. Two uniform rods AC and CB each of weight W are smoothly jointed C, and the ends A and B are connected to the points the same level of the inclination of the rods to the horizontal 60 degrees. Find the reaction at C. The same idea we done already. Question number 4. Two uniform rods AC and CB, each of weight W, are smoothly jointed C. The ends A and B connected to 2 points at the same level if the inclination of the rods horizontally 60 degrees. Okay.